I'll have it. Give it to him. He wants it.
George, hand me your favorite.
Oh, what a reasonable man. What a good man. So good. Nice. What's the relationship? What? Inputs or outputs? Yeah, I'm not good at it. That's not answer. I'm dying. It smells like bad. What? It smells like Gabe. It smells like Justin. What? I know, that's why I said it.
Okay, I'm gonna shorthand these on the sideboard because I'm gonna refer to them. What did you guys write down for relation? Input. Okay, what did you write down then for is it function X or function? Relation. Okay. It's a relation with a rule. Okay, so a relation is like anything, any relationship, anything out there. A function has rules to it for each input. Each input can only be paired with one output. Like in a relationship, one person paired with another, one input and one output. It's a functioning relationship. Alright, what did you guys put for domain? What does it say for domain? Possible independent? What kind of value? Input. Okay. I'm gonna add to that. And I'm gonna go ahead and tell you guys that typically it's a list of X values. You guys remember that from last year? Yes. That your domain is usually X's. Now the book didn't tell you that. The book didn't tell you. The book didn't tell you that domain is usually X's. So that's a big tip for me to you. Domain is your X's. What's range then normally? The Y's. So the book tells you set of output, but you don't generally remember that. So what I'm telling you is it's a list of Y values. Okay, that's the real stuff. And then I'm gonna go ahead and just tell you that the independent variable is usually the X's, and the dependent variable is usually Y's when we're looking at ordered pairs or points. Okay. So you're supposed to write down the definitions in your book, but what I have is just kind of how I'm going to talk about them. All right. So let's get into this. Okay. Chapter 3. Alright guys, you're actually gonna go ahead and do this on page 173. You can write right on your book. You buy an item from a vending machine. Describe two relations associated with the vending machine. Wait, Miss, what are we doing? You're trying to look at the vending machine and think about how that is an input and an output and come up with one relation that you can see in that vending machine. How is a vending machine a relation? The heck? I wish I would just call it a relationship. What's the relationship in a vending machine? You got it?
Yeah.
What is it? Alright, so let's talk about two specific ones. Right here. But can anybody tell me one specific relationship in this vending machine? It is, it's all about money and food. So let's do one specific one. What do you guys want to do? The water, the juice, the pretzels, the cereal? Okay, so I'm gonna say if I input $1, the output could be popcorn. Okay, that's one relationship. Is there anything else for $1? Or if I input $1, maybe I get out cereal. Okay, so the input's the money, the output is the food that you get. That's the relation. So what are the inputs? I heard someone say this. The inputs are the money, and the outputs are the food. Does each input pair with exactly one output? So is this a function? What do you guys say? No. It's a no. The answer is no. It's okay. I mean, 50-50 shot. No, because if I were to tell you, hey, I put $1 in the vending machine, would you know what food I got? No, that's not a function. Okay. If it was a function, every time I put $1 in, I would get the exact same food out. But right now, if I put $1 in, I could get popcorn or I could get cereal. So that's not a function. Those are relationships, but they're not functional. No, because $1 has many outputs, has many output options. So this is not a function. And I know it used to be we only started talking about this in Algebra 1, but I know you guys have been talking about this for a while. Winter, what are you doing? Take your earbud out, put your phone away, get your hand up, and you're allowed infractions. Yeah.
Why wouldn't you be able to like do like a granola bar or something that's less than $1?
You could. You could have picked anything. I only picked $1. You could say input 50 cents, output $1.
If you input $1.
Oh. Yeah, if you input $1, the machine will give you popcorn or cereal because the money's right there, or a water bottle. Oh yeah, and then you could also, you're right. There's way more options. And then you could get the 2 granola bars. Is that what you're saying? Yeah, you're totally with it. And there's something else? Cheese? No, those are 70. Oh yeah, and you could get 75 cents. And get change back. Totally. You could totally get it. Alright, in math, function is one that pairs inputs with outputs. How can we use a coordinate plane to represent a relationship? What are the inputs? So, you guys, inputs are x values, outputs are y values. Know it. This is a relation right here. Is it a function? I don't know. This is a popular answer these days on the test. Okay, let's look at my x's and let's look at my y's. Great question. So your x's are down here, and your y's are up here. So let's say I'll do disordered pair first. That's 1, 3. So I have a 1 and a 3. I'll circle a point and I'll call on you guys. Orange. Can anybody tell me the coordinates of this orange point? What's okay? 3, 2. Good job. I didn't call on you, but good job anyway. Red. What's the coordinates of the red point? Yes. 3, 5. Stop. Not a function. Okay. Because if I asked everybody in here, X is 3, what is Y? Some of you could say 2, and some of you could say 5, and you would both be right. So we don't define that as a function. In math, they want one answer. If I say 3, you should tell me one answer. Everybody says the same answer. If there's more than one answer, we don't call it a function. We don't want to work with it. It's too sporadic. It's unpredictable. And mathematicians like very predictable things. So if X is 3, I should have one or the other, not both. X equals 3 has 2 outputs. No function. Okay? Yes, question? Okay, the other way, have you guys heard of the vertical line test? Where you draw a line up and down? If you can draw an up and down line, whoa, that's a huge up and down line. I don't know why it went like that. If you can draw an up and down line and it hits 2 points, that's when you're going to see this x value has 2 y values. So I'll go ahead and tell you about that right now. Vertical line test. Yeah. If an up and down line hits in two places, then you say no function. Okay? Does this even feel like math? I mean, I'm not adding or subtracting.
How would you know where to put it? To learn it.
Anywhere.
Anywhere?
Yeah, anywhere. So, like here, fine. 1 point, cool. 1 point, cool. 1 point, cool. Still function, cool, cool. And then I get here and I'm like, no, not a function. So technically, you put it everywhere. You know what I mean? That was a good question. Who else has a good question? Okay, you guys good? You got a good question for the room? You could say it for her.
No.
Just next time pretend it's your question. Alright, okay, so either you can list the x's, and if there's the same x with different y's, you say no, not a function. Or you can draw a line up and down, and if it hits twice, not a function. Okay, so there's many different ways to say yes or no on the function. Horizontal's good to go. Green light, go. Because a horizontal line, like, let's say I put a point here and here. This is 5, oh wow, so many times. This is 5, 5, 7, 5. The x doesn't repeat. Okay, let's move on. Next page, determine whether relations are functions. So, when I look at letter A here, it's presented differently, but what you want to do is to check every x. Did y'all turn the page? Page 175? Yeah. Check every x. Is there any x that's getting with 2 y's? Because if it is, that's not functioning. Don't function like that. Every x should go with 1 y. How's it look? Yes, A is a function. I don't see x getting paired up with more than 1 y. What about letter B? Which x value ruins it for letter B? Letter B, no function. X equals 4 has y equals 0, and x equals 4 has y equals 3. That's a thumbs down, 4. What are you doing? Pick one. Don't do both. Pick one. You want to talk about the 2's, Tavis, in letter A? You want to talk about the 2's in letter A, or are we good? We're good? This little guy here, what's this called? I love that diagram. I think it's called a mapping. A mapping diagram. Yeah. I know mapping seems like a verb or something, but yeah, that's called a mapping diagram. And it draws arrows from inputs to outputs. So this is yes function, because each x just has one y it goes to. Even though the 15 repeats, that's okay. As long as the x's don't repeat. So what you're seeing in this example is a list of points, a table, and a mapping diagram. So they could present these in a variety of ways. All right, you guys go ahead and do 1 through 4. All you have to do is really say yes or no. All you have to do is say yes or no. And explain it would be best.
Yeah, I'll hold on to this.
Environmental and biophysical and
Alright, number one is a no. I don't have it. Which X value ruined it over here? X equals 5 ruined it. It paired with 0 and 10. Number 2, yes or no? Yes. Number 3, yes or no? Yes. Number 4, yes or no? No. X equals 1 half ruined it. 1 half goes to -2, 0, and 4. You can't do that. If I was to write number 4 as an ordered pair, it would look like this. That's a point. That's a point. And that's a point. So a mapping diagram listed as points looks like this. It's 3 different points. The 1 half is paired here, it's paired here, and it's paired here. Okay? You see it as ordered pairs, okay? Okay, let's move on then. Next page. I already told you guys about the vertical line test. So turn your page and see it. This one is a pass vertical line test, and this one is a fail vertical line test. It goes through in 2 places. If it fails, you write no. Yes and no. So let's look at these. I'm going to draw straight lines. Boom, right there. Fail. It fails twice. You're right, it's a double failure. That one fails in 2 places. Letter B. Pass. Pass, yes, function. See the difference or no? Pass, fail. Alright, go ahead and do these. Page 177. Pass your bill, pass your bill.
Is that the next page?
Right. What do you mean no? Check it, hold on. Check it. That one. That one. It's happens. Not me. Oh, you said more. He needs more. That's why he ate normal. I don't need more because I lost my parents. You had it even with Bernie. You were born in the tube. Get your origin story right. You were born in the tube. What? What about socks too? What? I'll take your socks. No, keep on your. What? Oh yeah.
Let's see here. No function. That's a fail. Boom, fail. This one, yes function. Boop, 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 yes function. This one, yes function. This one's also a yes function. This one is a fail. No function. Fail. Fail. This one, yes function. Alright, questions on that? Easy peasy. Alright. Domain range. Set of all inputs, set of all outputs. So let's talk domain range here. So when it says find domain, make a note here. That means list X values. And when it says find range, that means list Y values. So you have to write the ordered pairs. It even says that. It says write the ordered pairs out. So we already practiced this. You write out the X comma Y, X comma Y. And then you list all the X's as inputs and all the Y's as outputs. Now, when the dots are connected, when points are connected, you have to use inequality symbols to show a whole range. It's a compound inequality from last chapter. All right, you guys try these. Try 14 through 16. Page 178.
Do you have to write equality?
Only when the points are connected.
Oh.
So this point is
Miss, what if I did a T-chart?
that's great. Fine. T-shirt's good. So the domain for number 14, -2, -1, 1 and 2. I ran out of room. Shoot. The range would be 4, 2, 4. The only thing about a T-chart is you probably wrote 2 twice.
Oh, yeah.
It's okay. And then in my list, I don't write it twice. So I actually need to erase the 4. So the range as a list is just 2, 4. So, yeah. It's just 2s and 4s in the Y value. Okay, 15. Okay, why don't you just finish? That's good. Okay, so 15 stopping point. So 15 starts at, what is that? It's -1, comma 3. And it ends at 1, 2, 3, 4. It is at 5, -1. So the domain is the x. So for domain, I will just do the x values. That means the x is going between -1 and 5. It starts at -1 and it goes through 5. The range, the yellow, the range goes from, and I'm going to put the smaller number first, -1 to 3.
I think you numbered it wrong. Because there's a 1. So I think it goes by halves.
Oh my gosh, it goes like half. Oh no. I have to do this all over. Do you guys see it?
Yeah.
Thank you for speaking up. So now it starts at -0.5 and it goes to 1.5 and it ends at 2.5 and -0.5. So the domain would be and the range would be because it's going by 0.5s. Careful about the dimensions on these graphs. Just like that. Switch it up on you. Okay, try 16.
You're just about to say.
I'm gonna do 16 on this part. Okay, 16. The x value starts at 1 and it goes through 5. Do you agree that x goes between 1 and 5? What does y go through? Y starts at 0 and goes through 4. Where did I get 0 and 4 from? Does anybody see 0 and 4? Okay, so when I look at the y-axis, this is the highest point and this is the lowest point. So the y is everything in between. You see that? On the y-axis, it goes from 0 to 4. On the x-axis, it goes from 1 to 5. So you can take apart the x and y axis. The x is going between 1 and 5, and the y is going between 0 and 4. You have to see the axes is separate. So it's going to look like this for range and this for domain. What are your x's there and your y's? Okay, independent daytime variables. Wait, that's a lot right now. I'm actually just going to pause right now and let you guys work on the assignment together. I feel like I'm losing now. Alright, you guys have 10 minutes to do this assignment. A lot of it's just yes, no, pass, fail. I want you guys to talk about it with somebody you're comfortable talking about it with. It's page 181. Number 1 through 18.
1 through 18? I thought it said 1 through 8.